So our next question here, 8.2.12, and they tell us that M&M weights in Appendix B lists data from 100 M&Ms and 27% of them are blue. The Mars Candy Company claims that the percentage of blue M&Ms is equal to 24%. So the first thing that we actually want to get is the claim. So, and here they actually said percentage, so our claim P is equal to 24%, and the opposite of that then is P is not going to be 24%. So now that we have that written, we can form our hypothesis statement. And again, H sub O and H sub A are labels. They're not equal to anything. They're not less than anything. They're not greater than anything. They're labels. It is proportions in this case that are going to be equal or not equal to something. And that something is 24%. And in between them in the null is equals because it's always equals there. And then we need the strict inequality, which is the not equals. And do the quick R and the S. And it's, again, the null hypothesis that represents the claim. So I star the R. And what this means is when it comes time to write the conclusion, R is for reject. We're going to be talking about whether or not we have the evidence to reject the claim that. And what is the that? That is the percentage of blue M&Ms is 24%. And really it's, again, it's just the one word we're missing here. So our first part of it is going to be we have, and then what goes in there is either going to be sufficient or insufficient. So we either have sufficient evidence to reject this claim or we don't have sufficient evidence to reject that claim. We're going to find that out when we finish part E. But right now, writing the conclusion with respect to the claim, we're one word away from having that completely done. So for our tail of the test, we look at the alternate hypothesis, the inequality. That's a not equal. So this is a two-tail test. We want alpha. Alpha is the significance level. That's 0.05. We want our sample size. That was 100. We're going to want X. Now, X is the number of candies. They gave us a percentage of candies. They actually gave us 27%. But good news for us, we can take the sample proportion, multiply that by the sample size, and when sample size is 100, that's going to be 27 as well. That's only because our sample size was 100 though. So when you're reading through these proportion questions, pay attention. You know, there's a couple things you have to pay attention for when it comes to the number of successes X. Did they give you the sample proportion, in which case you have to compute it just like we saw back in chapter 7? Or like in the last question, they might give you both of the partials. They told us how many things were overcharges, how many things were not overcharges. Make sure that you're picking that right number there. Our rule of rejection, it's always going to start out, reject, null hypothesis, if p-value less than or equal to our value of alpha here, 0.05. And again, the p-value rule of rejection never changes its structure. It is always reject, null hypothesis if p-value less than or equal to. The only thing that changes is the number. So at this point, we're ready to head on over to statdisk. So let me change on over to statdisk. Let's just clear out the old one. So we're going to go analysis, hypothesis testing, proportion one sample. And our alternate hypothesis is not equal. Our significance level is 0.05, and this time our claim proportion is 24%. Sample size was 100. Our number of successes was 27. We can hit evaluate and plot. And what we see here is we've got our two critical values because it's the two-tailed test. But this time our test statistic falls in between them. It doesn't fall off in the tail. Our test statistic Z was 0.702. We're not even a full standard deviation away from what we claim to be true. This is a result that's very consistent with what we claim to be true, and we're going to see that play out in what our conclusion is. So our test statistic was Z equals 0.702. And again, Z and T, how many standard deviations away from the claim was your sample result. And then our p-value here, which again, I'm lining up underneath. Place value by place value lining up. So our p-value was a little bit over 48%. This was a this is a fairly likely sample to get if the true proportion was 24%. So, and 48% is certainly not less than or equal to 5%. So this time we fail to reject the null hypothesis. So our null hypothesis was that the proportion was 24, and when we're failing to reject it, that means we got a result that was consistent with that. So when we fail to reject the null hypothesis, we don't have the evidence. The way that you will normally see this written is they'll use the word insufficient there. So we have insufficient evidence to reject the claim that the percentage of blue M&Ms is 24%. And the last question, sort of the real world question that comes out of this, and very much so the real world question, should the Mars company take corrective action? Well, they would only take corrective action if there appears to be a problem. There would only be a problem if the percentage of blue M&Ms doesn't appear to be 24% overall for the population. And according to our results were consistent with that still being true. So if we don't reject the null hypothesis, the null hypothesis is the status quo. We didn't throw out the status quo, so there's nothing they need to fix. So no. Our result was consistent with the percentage of, that's a horrible B, sorry about that, blue M&Ms equaling 24%. And again, when we're writing real world interpretations, like anything that you write, your first draft may not be your final draft. There's been plenty of times where I've written a conclusion, thought to myself, I can say it better than that, and I go back and fix it. Feel free to do the same yourself.